Hello and welcome to the Pharmacy Informatics Professor 2020 with your host, Dr. Armin Simonian. In order to be a good pharmacy informaticist, you don't necessarily have to be a computer programmer. You don't have to know programming languages, but it is important to know the basics of programming logic, and in order to communicate with the IT department, with the programmer that's going to help you develop an application, it's good to know programming principles so that you can speak to that person, speak the language of the IT department, speak the language of the programmer, and discuss the logic, the flow of the program, conditional statements, what you want the program to do. Now, of course, it doesn't hurt to take programming languages, and I know of pharmacists who are programmers who have built a career in pharmacy informatics around writing applications and have also continued to write programs or enhance their systems through using database languages for statistical analysis, for reporting, for building labels and expert rules and other applications. So today, what I wanted to do is talk about programming languages. Specifically, I'll do a little review about programming principles and the basics of the computer, just as a refresher very quickly, and then actually get into programming languages. A lot of students and even pharmacists that are interested in pharmacy informatics ask me which programming languages or language they should learn, if there's one that they should learn. So hopefully this video will help answer that question. So let's get into it and look at the presentation. And I will share my screen and start up this presentation on pharmacy informatics programming languages. All right, so just as a quick review, let me go through and talk about things in a computer program. So we have data structure. We have to have a way of modeling the data to list it out either in tables, lists, arrays, records, files. We have to organize it in a way that we're going to be able to communicate with the computer's CPU, send that information in and out of the CPU, and process it. There needs to be a sequence of instructions that will solve the problem that you're trying to solve. So the application really is to solve an issue, to automate something, to get something into an app. And so we need to have those instructions. And then the program is the algorithm using the appropriate data structures in order to solve a given problem. So you have your data, you have your instructions, you put those together and you get a computer program. Okay, if you remember, we talked about data. These are pieces of information. Every computer has a central processing unit, a CPU, and within that can be a arithmetic logic unit. So basically all these computers, what they do, every computer, you can break it down to some very specific things that the computer does. And when you're processing data, you're either doing a comparison or you're doing some math on the data. Everything we do on the computer is based on comparisons and math, okay? Now, when we talk about in and out, input and output from the CPU, what we're doing is we're getting data, we're executing some instructions around that data, and then we're writing it back out either to the screen or to a hard drive or a flash drive or random access memory somewhere. So we're getting it, we're processing it, we're writing it back out, and they call that fetching, executing, and write back, right? So here's a picture of a CPU. And when you fetch the data, you see these little data highways. Information is coming into what we call registers. And then you have your CPU that can do all of the instructions. Instructions are executed, and then you can write it back out. and it goes to memory or to a screen or somewhere else. Okay. And here's the place where we do arithmetic, the arithmetic logic unit, and then the control unit. Okay. So we have instructions and we have data, and that's all that the computer is doing, is taking data and processing it. All right, so let's specifically, now that we've done that background, get into some programming languages. And this is an example of IBM PC assembly language. This is what we call a very low-level programming language. It doesn't look anything like English. And every little thing, every piece of information, every instruction that you do that affects that information has to be written out. It's very tedious. And basically, you're talking to that CPU and you're saying, go get this little bit of information, bring it into the register, go get this other piece of information, bring it into the register, compare it one to the other, and then go on to the next step. If you were to read this program, which you can by looking at the comments that the programmer added on the side, all this little program is doing is saying, get a number and store it, and we're going to call that a variable AX. And you want to compare it to 97. If it's less, then you're done. Okay. And then if it's not less, you're going to go on to the next step, right? Because you're not going to jump to done. And you're going to compare it to the number 122. And if it's greater than 122, then you're done. Because what this program is looking for is the number within the range of 97 or 122. So first of all, if it's lower than 97, you're done. It's not in that range. If it's higher than 122, you're done. It's not in that range. And then you're going to subtract 32 from AX and return to the main program. So if it's not less than and it's not greater than, then the program is supposed to subtract 32. I don't know why. And then that's when the actual procedure ends. Okay. So step by step, and you see these little instructions here to compare and to end the program, okay, return to the main program. So all of these have to be spelled out, and then you're showing the data that's being processed and what to do with it, okay? This is assembly programming language. Now, with any programming language, what you have to have that goes with it is a compiler or an assembler. And what that does is it takes this kind of human friendly, this is still considered human friendly because we have little instructions that are written out with characters that we can read, and even the variables and information is written out that way. And basically, you have to compile that and change it to a series of ones and zeros that the CPU is going to understand, okay? Have I used IBM assembly language? Yes, I have. So when I was preparing to do my residency, before I even thought about going and doing a residency in pharmacy computer systems, I was taking classes in computer basics, and I took some programming languages, excuse me, and I ended up using some of those programming languages during my residency and afterwards. So I'll talk about that as I go along. So this is one of the tools that was used in the first electronic application for pharmacy, which was a pharmacy computer system at a hospital where I did my residency. And that program was written by a pharmacist who also had a computer science degree. and he had used IBM assembly language and COBOL to do the programming on that system. So luckily, I did know IBM assembly language, and I did know COBOL. So before I go on, I will talk about the types of statements that we use when we get into some of the higher end programming languages. So what we talked about first was IBM assembly language, and you saw it was pretty crude. When we get into some of the higher level ones like COBOL and Pascal and others I'm going to talk about, you'll see something very common, and that is these conditional statements, such as if a certain condition is true, then do this, otherwise do this other action. And then you have something called loops, which is similar but stated in a little bit different way, and they act a little bit differently. So while this condition is true, do this action. And then we have a for loop for this condition, do this action. And then we have a repeat where we say, repeat this action until this condition is met. In other words, keep doing this instruction. Look at the next patient on the list and look at their age. And if they're not in the range, go to the next patient and go to the next patient. Go to the next patient until you find the right age or you get to the end of the file. Okay. Now, if you look at the address for the original Apple campus, they had a little bit of humor in their address. They called it one infinite loop. An infinite loop is a bad thing when you're doing programming. An infinite loop means you are doing a loop such as while this is true, do this, or repeat until this condition is met. But the condition can never be met because you didn't program it properly, or you didn't put the right flag in your file to end it out or to close it out. And so it will go on infinitely forever. And basically your computer gets stuck and dies because it cannot finish that program. It goes on forever. So we call that a infinite loop or do loop that never ends. Okay, so you'll see this kind of programming, these conditional statements in most of the programming languages that you study. Okay. Now I went to the IBM website and I looked at programs that were supported by the IBM operating system, and you'll see some names that you probably know. So these are the more common programming languages that have been used over the years. We have C and the next generation C, which was C++, BASIC, which was used a lot on the original IBM PC. And as the name says, it was a very basic programming language that was used a lot. Not sure if it's used very much anymore. You see COBOL on here, which is a business-oriented language, one of the earlier languages that were used for a lot of computer systems. And because of that, we still have a lot of computers today that use programming that was done in COBOL. If you look at ATMs, ATM machines where you go to get cash, 95% of those run on COBOL programming. So it's legacy programming. It's still out there, but it's still being used. Okay. Pascal is a programming language that was really meant to be a demonstration language. It was supposed to be a language that was used to teach people how to program at a basic level or a fundamental level. And it ended up being used in business. There was a compiler that came out called Turbo Pascal, and it was at the time very cheap. It was like $50 to get the compiler, and anybody could write a computer program using Pascal, compile it and put it on a computer, and it would work. It was really something fun. So some of these other languages used more in the science field like Fortran and RPG. These are still out there, but not used as much. So we still see a lot of use of C and C++ because C is the programming language of the internet. Okay, so C came from a group out of that was developing Unix, the Unix operating system. And when the internet was being developed and growing, it was really based on the Unix operating system and the C programming language. So C is used a lot if you want to get into programming in the internet world, or really in anywhere in the business world. C is a good language to know. All right. So an example of COBOL. So COBOL, something interesting is that you have to have line numbers. And a lot of times what we did when we programmed is we'd set aside blocks of numbers. So you see in this program, it jumps from 100 to 200. Just in case I want to put in more lines of comment or something at the beginning of the program, I could have line 101, 102, 103. It would give me some space without having to rewrite the whole program, because once you've set those line numbers, they're in cement and you couldn't change them. And so what we would do is make sure that we made room between those numbers to put more statements. But this is a very simple program, and this is what it would look like, about displaying the words "Hello World" on the screen. And there's some overhead that has to occur. You have to set up your data, you have to say where it is, and then you have to actually start your instructions. And there's, as with any language, French, Italian, or English, and any computer language, there are vocabularies that you have to use, and there's grammar that you have to follow, grammar rules. And so this is true in all programming languages, and you see it here with COBOL. So this is an example of COBOL. Did I use COBOL after I learned it? Yes, in that residency that I did, that computer system, that pharmacy system was written using IBM assembly language and COBOL. And so I actually did some COBOL programming during my residency, writing a little application where a nurse could go into the pharmacy system and request a missing dose or a refill on medication such as antacids. Or if any unit dose was missing, we could send up another one. They could request it, it would print a label in the pharmacy, and we could dispense those medications. So that was written in COBOL on a pharmacy system. This is an example of Pascal, a program that I like a lot. It was very interesting and easy for me to learn and use. And you see here that there's a program here that's doing some comparisons again. So at the beginning of the program, you see that you define your variables A and B. They're numbers. They could be integers or real numbers that have a decimal. It could be a character, or they could be a Boolean logic, true or false. And so in this case, we have two numbers, and we're going to have the computer read those numbers. And then if number A is greater than B, then we're going to write on the screen A is greater than B, and we're going to substitute whatever those numbers are into the A and the B spot. And then if A is equal to B, so if A is not greater than B, it's going to go on to the next step, right? Which is A equal to B? And if they are equal, then it'll write on the screen A is equal to B. And then if that's not true, it's going to go on to the next step, and it's going to compare to see if A is less than B. And if that's true, then it's going to write on the screen B is greater than A. All right, and that would be the end of the program. Now we could have put in if then else on this, whoever programmed it didn't write it that way. But there is a way to rewrite this program. And that's another beautiful thing about programming. You can accomplish the same thing in a lot of different ways using any given programming language. So you'll notice that some programs, if you get into this and you start reading programming logic, you'll see that some programs use a lot of economy of lines and verbiage in their programs, and they're very efficient, and others seem to want to spell everything out and do a lot more steps. They both work just fine. You know, one is a little bit more compact, but there are different ways to tackle the same problem. All right, and I know this screenshot looks a little bit fuzzy, so don't worry, it's not your eyes, but this is an example of structured query language. So this is something that now we're getting into database languages. And this one is very popular and important in pharmacy. Have I learned it? No, not specifically, but I've seen SQL or SQL code before. And this is something that's very important because the major EHRs, such as Epic and Cerner, use a form of SQL to write reports, to develop labels, to write expert rules. These are all using some kind of flavor of structured query language, or SQL or SQL. Those are all the same program, different names for the same program. So usually when a pharmacy student or a pharmacist asks me, which programming language should I learn, I usually recommend SQL at the top of the list. Why? Because if you're going to be working on an EHR and you're going to be doing any of those areas of developing labels or reports, doing analysis of your data, data analysis, or writing expert rules, that SQL, that SQL is really going to come in handy. And I do know pharmacy informaticists that full-time are using SQL in developing programs and analyzing data at their institutions. Now, getting back to C, there has kind of been an evolution of C. So remember I said C was the programming language of the internet. And kind of the next step after C that was built on C, used on the internet, was a program called Java. And now the latest iteration of this is a programming language called Python, where basically it's based on C. It kind of looks like C, but it's a lot simpler and a lot easier to learn and to use. So nowadays, I do recommend learning Python because it's something that you could probably easily teach yourself. And it is used a lot in the area of artificial intelligence and data analysis. And so I think Python is probably a newer language that I would recommend if you are interested in learning a programming language, and that specifically could relate to pharmacy informatics and what we do in our work as pharmacy informaticists. And then lastly, I wanted to show an example of R programming. R programming is like the workhorse when it comes to data analysis. And so if you're really into data analysis and you want to learn a program that you can use for that, this is also used a lot with analyzing the human genome and doing genomic data analysis. And so R is a really good program for that. If you have large data sets, a lot of data, and you want to do some very deep analysis of that, then I would recommend the R programming language. I have not learned this language, but I see it used a lot all around me in these areas that I've mentioned. So another good choice. So we've talked a lot about different programming languages, going all the way back to lower level language, IBM assembly language. And then we talked about COBOL and Pascal and C and Java and Python and R and SQL. So again, you know, it's hard for me to say just learn one language or the other, but specifically focused in on pharmacy informatics, I would definitely recommend a program like SQL, structured query language. And then if you want to get into areas of artificial intelligence and data analysis, I would probably recommend Python and R. So that's my little tour of programming languages, and I gave you a little history and stuff that I've done with languages, and I hope that was helpful for you to understand the application. One other thing I'll mention is the Pascal programming language. So when I finished my residency, I did work with two of my colleagues, and we wrote a pharmacokinetics program using the Pascal language, and that worked out very well at the time. It was used by a lot of different institutions across the country. Eventually, that program was sold, and it was converted into the Windows environment. They rewrote the program. It was no longer written in Pascal, but Pascal was useful in that way. So just to complete the whole picture of the type of programming that I've done, I have done programming in assembly language, COBOL, and Pascal. And those were all very useful. All right. So again, if you're interested in a programming language for the pharmacy informaticist, I would start with SQL, and I would also nowadays recommend R and Python if you're really into data analytics. With that, I hope this was helpful. I'll say stay safe, stay healthy, look after the health of others. I'll continue to work on more episodes, and I hope to see you next time. If you like this video, please indicate that, like the video, and subscribe to my channel, and I'll thank you for that. So until next time, take care.